Welcome to Precalculus Concept 11E, complex numbers, and today we're going to solve quadratics with complex imaginary solutions, and there are 3 boxes. So here we go right now. Whoa, too far, sorry. The first box is all about the quadratic formula, so hopefully you remember what the quadratic formula is. In case you don't, the quadratic formula is this: x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Hopefully you remember that. I want to talk really quickly about this part. This is called the discriminant. Okay? I'll just abbreviate for just DISC. It's called the discriminant. And what it does is it tells you the number of solutions that the quadratic actually has. So the discriminant can be one of 3 things. Okay? The discriminant can be a positive number, the discriminant can be a negative number, or the discriminant can be the number 0. Okay? If your discriminant is a positive number, that implies that there are exactly 2 real solutions to the quadratic. If your discriminant is 0, it implies that there's exactly 1 real solution to the quadratic. And if your discriminant is negative, what it used to mean is there was no real solution. That's probably what you learned in Algebra 2. But in Precalculus, we want to go further and say that there are 2 complex solutions, and not just any 2 complex, they're complex conjugate solutions. Okay? So this is where we're going today. We want to be able to understand this part here, that when we solve quadratic that has a negative discriminant, there's going to be 2 complex conjugates. Box number 2 is an example. We're going to solve this quadratic together. It says 3x squared minus 2x plus 4 is equal to 0. I'm going to teach you the 3 steps that I teach all of my students when they solve a quadratic. The first step is very, very simple. You just write down the values of a, b, and c. The value of a in this case is the number 3. It's right here. It's the coefficient in front of the x squared. The value of b is the number negative 2. It's the coefficient in front of the x. And the value of c is the constant term, which in this case happens to be 4. That's all you got to do for step number 1. For step number 2, you only write down the discriminant, b squared minus 4ac. And then you determine how many solutions this thing has. So b squared, so that is negative 2 all squared minus 4 times the value of 3 times the value of 4. Negative 2 all squared is the number 4. 4 times 3 is the number 12. And then 12 times 4 is 48. So this is negative 48. 4 minus 48 is negative 44. So right here, I know that because my discriminant is a negative number, that means there's going to be 2 complex conjugate solutions. That's a really important step in precalculus that we want you to know. Okay, step number 3, we solve this quadratic just like we normally would. So x is equal to negative b plus or minus b squared minus 4ac all over 2a's. And then we keep going. So the opposite of b would be 2 plus or minus the square root of now all your hard work that you did in step number 2 for a value of negative 44 plays out right here. Okay, that's what you want it to be. So since you now know that, you can just plug in the answer of negative 44. Pretty straightforward. Let's figure out negative 44. All divided by 2 times the value of a would be the number 6. And then we just simplify this thing, you guys. So this is going to be 2 plus or minus the square root of, I'm going to say this is the square root of negative 1 times the square root of 4 times the square root of 11. All divided by the number 6. Hopefully you see what's going on here. The square root of negative 1, because I have an I in here, I have an imaginary unit. 4 is the largest perfect square I can pull out of 44, and then 4 times 11 make 44. So moving right along and keep going here, I have 2 plus or minus. Remember that the square root of negative 1 goes to I. The square root of 4 goes to 2. So I get 2i square roots of 11 all divided by the number 6. Keep going here. I can factor out a 2 from the numerator. That leaves me with 1 plus or minus I root 11 all over the number 6. Now hopefully you see 2 and 6 can cancel to give me 1/3. Okay, so then what I'm left with here is 1 plus or minus I root 11 over 3. But writing this in standard form with complex conjugates would be 1/3 plus I root 11 over 3 and 1/3 minus I root 11 over 3. So your answer is most likely going to be presented to you in a solution set of complex conjugate pairs, 1/3 plus I rad, oh, this would be 11 by the way, rad 11 over 3, and 1/3 minus I rad 11 over 3. Okay, box number 3 is a U-try. Go ahead and solve using the quadratic formula, x squared minus 2x plus 2 equals 0. And just as a hint, you should get imaginary complex conjugate solutions. Okay, so go ahead here and take a look at the solution. Hopefully you got the right answer. I got -4 for my discriminant, meaning there's 2 complex solutions. So my answer should have been 1 plus I and 1 minus I. Hopefully you got that correct.